Welcome to Dr. Balika's podcast for the Curious Dog. Today is June 13, 2026. This video is on a Nature article published on the 10th of June 2026 titled Mutation-Dependent Responses to Sleep and Exercise in Clonal Haematopoiesis. Clonal haematopoiesis increases inflammation and atherosclerosis risk. This study examined whether sleep and exercise modify clonal haematopoiesis clone expansion and mutant cell programming. They used the UK Biobank and all of the US cohorts for human analysis with actigraphy-derived moderate-to-vigorous physical activity and genomic sequencing for clonal haematopoiesis. They used multivariable logistic regression and meta-analysis for statistics. Experimental studies included atherogenic mouse models with JAK2V617F, TET2 loss of function, TRP53 loss of function, and DNMT3A RH78H clonal haematopoiesis exposed to sleep fragmentation, uninterrupted sleep, or exercise. What did they find? In the UK Biobank, they found that moderate to vigorous physical activity was associated with lower non-DNMT3A clonal haematopoiesis prevalence, odds ratio 0.87, p-value equals 0.019. In the all of the US cohort, a similar trend with the odds ratio of 0.84, p-value equals 0.052. Meta-analysis, odds ratio was 0.86, p-value equals 0.0025 for non-DNMT3A clonal haematopoiesis. Sleep and exercise curtailed JAK2V617F and TET2 clone expansion, but not TRP53 or DNMT3A RH78H clones. Sleep and exercise reduced JAK2V617F and TET2 and TRP53-driven atherosclerosis. There was no benefit in DNMT3A RH78H clonal haematopoiesis. Mechanistically, sleep and exercise selectively reprogram mutant progenitors and macrophages through interleukin-1 beta signaling, inflammasome pathways, and adrenergic signaling. Limitations of study: predominantly mechanistic and preclinical data. Mutation-specific findings may not generalize to all clonal haematopoiesis variants. Human analyses were observational and cannot establish causality. The key takeaways: healthy lifestyles exert mutation-specific effects on clonal haematopoiesis. Exercise and uninterrupted sleep can selectively suppress inflammatory programming and reduce cardiovascular consequences of specific clonal haematopoiesis mutations. Clinical pearls. Clonal haematopoiesis is biologically responsive to lifestyle, but responses depend on the driver mutation. Non-DNMT3A clonal haematopoiesis shows the strongest association between physical activity in human cohorts. The JAK2V617F and the TET2 mutant clones are particularly sensitive to sleep quality and exercise. Interleukin-1 beta appears central to lifestyle-mediated suppression of mutant clone expansion. Exercise promotes metabolically healthier mutant progenitor cell states. Sleep fragmentation accelerates inflammatory signaling and atherosclerosis in susceptible clonal haematopoiesis genotypes. DNMT3ARH78H-driven clonal haematopoiesis showed relative resistance to lifestyle intervention in this study. Lifestyle interventions may become an adjunct precision medicine strategy for selected clonal haematopoiesis mutations. This is an infographic on this paper. Hit pause and read at your leisure. Podcast brought to you by masterbedfacts.com. This podcast is for physicians and healthcare providers. If you enjoyed this video, please like, subscribe, and forward to your friends.